Hi, I'm Grace, and welcome back to Code with Grace. Today we are doing a daily Leetcode problem. Technically, it's yesterday's, but it just took a while to understand. It is 1653 minimum deletions to make string balance. It says here that we're given a string S. Can you see? I'm going to highlight. Consisting only of characters A and B. And here we can delete any number of characters in this string to make the string balanced. And the definition of the string being balanced is if there is no pair of indices ij such that I is less than j and the character at I is b and the character at j is a. Which is to say, basically, a string is balanced as long as there is no b that comes after an a. So all a should be preceded by a's only. Um, and B should follow. All B's should have A's before it, B's after it. Okay, so the approach we're going to use is actually uh, this one. Let's give this a go. Mm, A, B, A, B, B, A, B. A, A, B, A, 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 B, A, B, B, A, B. B, B, A, B. This is our string. Okay, so we're gonna basically take every point and use that as the separating point. So at this point, all the characters on the right that needs to be deleted in order to make this. No, let's start it over. Okay, so this here, if we just look at this string, what do we need to do? All the A's should come before all the B's, and the only action we can do to make it balance is to delete something. So the optimum way, because we're doing minimal deletions, is to delete this guy and this guy. Thereby, we have A, and B. So how do we know that? The way we can know that, because we could also delete, let's say we're here and we just delete all of these B's. So that also makes a balance, but then we have to delete 4 items and we want to minimize the number of deletions that we have to do. So the way we can do this is actually by counting the number of invalid characters to the right and the number of invalid characters to the left. So whatever point we are at, invalid to the right would be if there are any A's to the right. So there's one A here. And if there are any B's to the left. So here it would be 1. And then we sum up the values that are invalid, which is 2, and at every point, we're gonna have this. Let's take a randomly this guy. The number of invalid characters to the right would be A. So 1, 2, there's 2 A's to the right. The number of invalid to the left is 0. So this is also 2. That's not a good one. Let's do this guy. So number of invalid characters to the right, there are no A's. There's in fact nothing to the right. So that's a 0. But the number of invalid to the left is 1, 2, 3. There should be no B's to the left. So this results in 3. 1, 2. Actually, this should be Learning with Grace. This channel should be called Learning with Grace. Okay, so here, what we're saying is that the invalid characters to the right is actually 1, 2, and actually, no, that was correct. Okay, all right. So let's give that a go. And just to illustrate, I'll do this. So what if we have just all A's? Do we need to flip anything? Do we need to delete anything? No, that's a 0. And how would we know that? Well, let's take this guy. Are there any invalid characters to the right? Yes, there's two. Okay. Are there any characters to the left? Are there any B's to the left? No. Here, invalid characters to the right. Yeah, and then we want only B's to follow this midpoint. So there's one. Are there any invalid to the left? That's a zero. Are there any invalid to the characters to the right? No, there's no characters. Um, so that's a zero. Are there any invalid to the left? Nope, nope. A's are good. It's only invalid if there is our B's, which they are not, so zero. And so this is the optimal, which is the minimum number of deletions required to make the string balanced. So our approach will be to first count the number of B's. So we're going to have a few variables here. Let's say we have a B's and the number of A's. Now we're going to go left to right. So let's first have the number of A's. So A's will be, we can just do, we'll count the number of A's, which is one, two, three. Actually, let's count all four. So one, two, three, four. There's four A's. And then B's will start at zero. Then, and then once we iterate, we'll say, okay, step number one. Step number one is the current letter an A? Well, if it is, then we need to exclude it from our count of invalid characters because whatever our current position is cannot be invalid. Whatever our current position is, whether it's an A or a B, because we're explicitly checking for invalid characters to the left and right of us, our current position is always valid. So let's handle the A's here. Might make more sense in code. And then check the results, which is the total count of invalid to the left that we have to handle and the total count of invalid to the right that we have to handle. Sum it up, we get some value and we want to optimize for the minimum of all those values. And then step number three is, let's say it's a B. If it's a B and we're currently at a B, as soon as we move away, because remember step two, we already handle the current steps imperative, which is to get the total number of deletions required to make the string valid at our current position. So if the current character is a B, that means once we shift to the right, which we're doing, we're going left to right, then that now becomes an invalid character. So we handle the B's and increment it so that when we get to the next guy, our B's will be updated with 1. This is one of the scenarios where it actually makes more sense to do this in code. So let's give that a go. So first, we have the number of A's. So let's say that is A's count, and that's going to be S dot count of A. So if we're first saying that, remember, we're going to go left to right. So all the characters to the right, which are A's, are invalid. All the characters to the right, which are valid, are B's. We want A's followed by B's. And remember that example where we had just A. The way we're approaching this allows us to optimize and find the minimum number of characters to delete. And so the code will make more sense. Okay, now the B's count starts at 0 because we're starting from the first character, and at that point, there are no B's to the left. In fact, there's nothing to the left. So B's count is 0. Let's make this more clear. A's to the right and B's to the left. This is going to get confusing. Res, let's set that to S because worst case scenario, and we are told that this has at least one character, worst case scenario is the length of the string minus 1. Why minus 1? Because whatever character you're at is always valid because we're checking it relative to its left and right. Okay, so let's set that to the maximum so that we can keep on finding and optimizing for the minimum. Then we iterate for I, C, and enumerate from left to right of our string. What was step one? Step one, first of all, if our current character is an A, we want to exclude it from our determination because whatever our current character is cannot be invalid. And once again, these two are keeping track of the invalid characters to the right, invalid characters to the left. Okay. I'm emphasizing that because that was very confusing to me personally, but let's continue. So we'll say A's to the right, we want to decrement it if the character at our current position is an A. So in this case, for instance, this will be true. And once we convert that to an int, a true will be returned as 1 and a false will return as 0. So if it's not an A, it'll just subtract 0. If it is an A, it will subtract the 1, excluding that A from this determination and all future determinations. Okay, now we say res will be the minimum of whatever it currently is, which is at the max possible, and then say, all right, at our current position, what are the invalid characters to the right, meaning how many A's are to the right of us, plus, and remember we excluded the current A if our current position happens to be an A. Okay, so the invalid A's to the right plus the invalid B's to the left, which at the beginning, there's nothing to the left. So this will be fine. And then what was step number 3? Step number 3 is handling the B's, which is because we're moving onwards, we're moving to the right in our enumeration from left to right. We say, okay, so we already made our calculation for this round. Let's handle the B's such that if the current character is a B, we do want to consider it for the next iteration. So we'll say B's to the left, because we're going to move away from it, will be incremented by 1 if and only if the current character is a B. Now, yeah, if it's an A, it'll just add 0. If it is a B, we'll add 1, and B's to the left will be incremented. At this point, as long as our logic is clear, we should just be able to return res. Let's first make sure I don't have any obvious errors. Give that a go. Okay, so yeah, description. All right, there we have it. So the main idea here was we're counting the number of invalid characters to the right, which is A's, because A's must be followed by B's, and the number of invalid characters to the left as setting a maximum and then optimizing for the minimum by processing this left to right, where the step is you first count all the A's because you're going left to right. So all the A's are invalid if it's to the right. And then you calculate the first, so for every position, you exclude the A and say it's not invalid. We're counting the invalid. We're reducing the count of invalid if the current position is the A because the current position can never be invalid. And then do our calculation by calculating, summing up the invalid ones on the right, which are A's, invalid ones on the left, which are B's. And then once we're done calculating, then we say, okay, for the next iteration, the current B, if it happens to be a B, will then be invalid because it will be to the left of whatever next character we're moving on to, and we are moving this left to right. Hope that wasn't too much. And this was 1653 minimum deletions to make string balanced. Thanks so much. And let's keep on coding. I'm your host, Grace. See you next time.